Really quick, I just want to ask, you still can't see where to upload the essay 2 questions for the midterm. Whenever we go to it, it still says cannot upload submission. And I think like when you click it for the details, I think it's still because the due date hasn't been adjusted, is the way it looks, but I've never set anything like that up, obviously. But that's what it looks like on our end, but it would not let us upload it.
Okay, I know I changed the due date to 2 weeks from now, actually. But I have to deal with that as soon as we.
It might be something in Turnitin, since it's a Turnitin link. Maybe, I don't know if you have access to go like into Turnitin and change it, but that might be why. Maybe it's not Canvas, maybe it's that extra software or something. I don't know.
Okay, I'll take care of it today, and if it doesn't work, we'll have to find another way to turn it in.
Thank you.
Are y'all able to do just the Microsoft Word or?
Yeah, Microsoft Word works fine.
Okay.
If you like, we can't upload it because the way the link is set up, but if you just change it to like a regular link, then we should be able to.
Okay, it doesn't really have to be turn it in. That's just the way it was before.
I think whenever you set up the assignment, whenever like it'll give you options of how you want it submitted. And if you change the submitting option to like a Word document, then we can do it.
Okay. All right, well, I'll get it straight today. Okay, I think the quizzes are open up to number 6, and I've just kind of been letting y'all go at your own pace now since you got started with the more difficult ones first. The next number 6 will be basically on the sleep, the sexual behavior, and of course learning and memory today. From reviewing things, mostly what I saw is that most of what we know has been learned from mice studies and from case studies like Henry M. We're coming back to him. He's the guy that had his hippocampus removed to cure his seizures. And there are a couple of other cases. Kent Cochran, there's some reading on him there. He was in a motorcycle accident and also had damage to his hippocampus and other brain areas. And the other case study was Jimmy G. He had a serious case of Kosakov's, which is usually the result of severe alcoholism and thiamine deficiency. Because of that, the thing that all 3 of them had in common was that all of their procedural memories or muscle memories remained intact, even though they had serious anterior grade amnesia. I think the take home there was that the first 2 did not have the retrograde amnesia to the same degree, which in research had a lot to demonstrate that memories are formed in the hippocampus and stored elsewhere in the brain in a process called consolidation, which occurs over a certain amount of time. The mice studies basically were of two forms, which are very common in psychology: classical conditioning and simple operant conditioning. Classical conditioning mainly involves the amygdala and the cerebellum. So the cerebellum has a second function there other than just balance. Cerebellum also stores memories for certain reflexes and conditioning, such as eyelid or blinking. And the simple operant is more associated with the basal ganglia, and it's more the habitual movements that person doesn't think about. And he also mentioned the para-hippocampus here, which is another part of the hippocampus that we hadn't talked about, that also has a lot to do with procedural memory. So encoding memories is the first step, and retrieving those memories is what happens further down the road. And this takes place mostly in the hippocampus and the right frontal and posterior regions of the hippocampus. The two types of memory, of course, are episodic memory, or which is a memory of recent events and things that we're conscious of. And semantic memory is another type of memory, which semantics are basically facts that aren't associated with emotion in any way, but just things that you happen to remember, such as trivia. And this just speaks about the types of amnesia. Henry M's case, with the medial temporal lobe removed, and mentions Kosokov Syndrome, which also involves the thalamus. And for a visual image, this was just showing in the pink here what was removed in the brain of patient Henry M. And it was the medial aspect of the temporal lobe. This slide here just speaks of consolidation. And consolidation is just the memory finally reaching a state where it can be stored long term. It usually occurs after a period of about 48 hours. So for the first 48 hours, the memory is pretty fragile and it hasn't been stored to long term. And solidification is another term that it's also known as once memory is stored. This slide just talks about it being a gradual process, and it mentions how a schema is very important in forming long-term memories. And the schema is just something that the organism, the mouse, has learned to do. So there is basically a reference point whenever new learning occurs. And by that being the case, the new learning is able to take place more efficiently. If rats are taught to do it at a random fashion, then it's not really consistent how well they learn. But the take home there is just understanding what a schema is because it's believed to work the same way in humans, that if that schema is in place, they're going to be able to form memories more appropriately. Anatomically, there are a couple of things that are very important here. The dorsolateral prefrontal cortex and the anterior cingulate cortex work in concert with the hippocampus in a region known as Area 46 on the Brodmann's map, which is this map right here. And that is this area. And why it's important is because this is where you hold your thoughts before they become memory. So basically, this is the executive area where you are focused on what you're doing, what the task is right now, and you're able to remember what you just did before that, and you're able to plan what you're going to do next. And this is the initial part of immediate memory or immediate short-term memory. And this is usually the first thing to go in a condition like Alzheimer's disease, because it does require a lot of energy to function. And it is believed that this area plays a role in repression of memories. This is something that Freud believed, that a lot of energy went into this to deny things or things that you don't want to remember, to block them out of your mind. Long-term potentiation, this can be a complex thing if you really get into the details, but what you really want to take home, what you really want to know is that as a process of learning, when glutamate binds to the receptors of the postsynaptic cell, it triggers a metabotropic effect on that postsynaptic cell or dendrite. And the end result is that the dendrite physically changes. It actually grows and becomes more efficient in transporting the charge. And this is believed to happen when we form new memories, is that the dendrites actually become stronger and they become bigger and they become more efficient. And this, of course, is a glutamate process acting on the NMDA receptor. And that at this level is basically what you want to have an understanding of, but it gets a lot more complex with that, with the magnesium blocking the channel and calcium being released, and a lot of details that clinically don't have a lot of relevance. If you were going into research in neurobiology, it would be something that you would probably want to know in a lot of detail. But the main point here is that the dendrite physically changes and it becomes bigger and stronger. And this is in the process of long-term potentiation. And this just talks a little bit about that. And this is another illustration of once the glutamate binds, it causes chemical reaction with the actin filaments and exocytosis. And as you can see, this spine is a lot bigger than this one. And this is the result that happens when a memory is formed, that there is a physical change there. The overall process of LTP is basically what I just spoke of. And again, getting into details, there is a protein known as PKM, and there is a receptor known as a AMPA receptor, which is the receptor that multiplies and becomes more available and allows for the plasticity or the memories to take place and to stick. Dr. Adams had mentioned here a particular protein or artificial peptide known as ZIP. And the relevance there is that in animals, it's been shown to cause memory erasure of up to 30 days. And it does that without any effect on anterior grade amnesia. And that raises an important ethical issue. If the, I guess, for conspiracy theorists, if the CIA or some organization got involved with using this, which we don't know that they already do, that could really be an ethical concern of erasing someone's memories. But it looks like we pretty close to having the potential to do that, even if it hasn't been done yet. Those are most of the, well, that's all the PowerPoints, but again, the script is very inclusive, and it goes into more detail than what I did there. And as I said, I really just think you need to understand the concepts here, but not so much the details of things, because it can get very detailed. And this was just an article of the passing of the second case study I talked about. That patient had contributed quite a bit to neuroscience with his particular brain injury. So that's where a lot of knowledge was accumulated about damage to certain parts of the brain and amnesia. And it's pretty short. If you haven't read it, it's worth reading. A couple of the other things are pretty long reading, or one of them is at least. But I would recommend that you read them when you have time. And this, again, is the first video we saw at the beginning of the class with Henry M. And you may want to review that. But there's nothing new with that. And this just gives a comparison of the 3 case studies. You've got damage to the hippocampus by surgery. You've got damage here in a motorcycle accident. And you have damage here in Kosokov syndrome. And the main correlating factors were that the first 2, they had serious anterior grade amnesia, and their working memory, or not working memory, but muscle memory and procedural memory actually remained intact. And that was the one thing that all three of these had in common is that their procedural memory was intact, despite the damage to the other part of the brain. And there is, I'm sure, at least one question concerning that on the next quiz, or number 6 quiz. Which again is 18 points, and I'll extend the time a little bit. I think 30 minutes should probably be long enough. You can take it twice. And I have looked through it, so it's not too difficult if you just know the material in the scripts from this meeting and from the last meeting we have, and you should be in good shape there. Did anyone have any concerns, or other than the essay questions? I'm going to find out what to do about that right now. If it's not fixed by say 3, please send me a message so that I can continue to do whatever needs to be done there. Or if you find it more convenient, you can just turn it in with the Microsoft if I get things set the way it should be there.
I did want to ask one more question. I'm sorry, I always ask you questions, but I just want to make sure that I know what's going on. So someone had asked, because we have like a group chat where we talk about the assignments and stuff for people who can't make it to the meetings. And someone had asked, I just wanted to make sure that I'm telling people the right thing. We're not supposed to do the summaries, right? Like the 2-page papers about particular topics.
No, I'm omitting those right now. It's just the quizzes and the discussions.
Okay, all right, thank you.
So if you're up on those, you're in good shape, but we're not going to do those papers and other things that was extra there.
Okay, thank you.
Okay, well, I'm gonna plan to meet with y'all next Wednesday, and we'll see where we are at that point. You can email me if you have any concerns, and I'm gonna see if I can get that fixed about the turn it in. Okay. All right, y'all have a good afternoon.
You too.